Cox, and here we're going to discuss formal charge and Lewis structures. And so formal charge is basically the overall charge of an atom or molecule, and Lewis structures are the visual representations of atoms' bonding sites as well as their electrons. And so first we're going to talk about the atoms and the charge. So atoms, you know that there's a nucleus, which is the center of the atom, and the nucleus has protons, better known as the positive charge, neutrons, which are the neutral charge, so it's neither positive or negative, and then electrons, which are the negative part of the atom. And so the protons and the neutron, they're going to be in the nucleus, whereas the electrons, they're kind of by themselves, they're in the electron cloud. They're circling around the nucleus, providing electric charge, atmospheric conditions around it. And they're usually the ones that are exchanged when it comes to ionic and covalent interactions. And so next we're going to talk about what a formal charge is. And so formal charge is the overall charge of an atom or molecule, and it's going to be the total of the positive and negative charges of an atom. So just remember, we're going to mainly deal with the protons and electrons. And any atom or molecule will have a charge or no charge, and this can be defined as its formal charge. And these charges play an important role when it comes to covalent and ionic interactions, because typically when electrons are exchanged, these positive and negative molecules will stable each other out. And so next we're going to talk about how you can calculate formal charge, but the equation is really simple. All you have to do is just count the different electron binding sites and non-binding sites. And the way you can remember this is by valence electrons minus non-bonding electrons minus bonding electrons divided by 2, and this is going to be your formal charge. So remember, the valence electrons, we'll discuss this in a little bit, minus the non-bonding electrons, the electrons that will be on the outside of the Lewis structure, minus the bonding electrons, the electrons that are being transferred in a reaction, divided by 2, equals formal charge. And the reason why we divide the bonding electrons by 2 is because usually the Lewis structures that we'll be showing will contain covalent bonding, and covalent bonding involves two different elements exchanging electrons, so there's going to not be just one electron per bond, but 2. For just this lesson in particular, you just need to understand that valence shells, or valence electrons, are the outermost electrons in the electron shell. And so the valence shell that an element can contain is 8. So valence electrons per shell is 8. It cannot exceed that. There's one exception, and that is for hydrogen and helium. They have 2 that they need to have in their valence shell. Hydrogen only has 1, but it can get rid of 1 or accept 1 to get 2. Helium already has 2, so it's already stable. And so it's wanting to reach 8 in its outermost shell in order to be stable, so it can fulfill the octet rule. And the octet rule is simply just finding 8 electrons within its outermost shell. And so if you just go down the periodic table in group 1, group 2, and then 3 through 8, you'll see that as you go down, they're going to have more and more valence electrons. So hydrogen has 1 valence electron, as well as lithium. Beryllium has 2. Boron has 3. Carbon has 4. Nitrogen has 5. Oxygen 6. Fluorine 7. And then helium and neon both have, helium has 2 and neon has 8, but they have full shells. And so now we've undergone finding what the formal charge equation is. We've figured out what a valence electron is. Now we're going to find the process to find it. So the process it's a 3-step process. It's really simple. First, you're going to find the formal charge of a central atom. Next, we're going to do the formal charge of adjacent atoms, so it can be multiple. It doesn't have to be 1. We're going to use nitrogen trioxide right here It's going to have 3 oxygens right here. We're going to find out the formal charges for all of them. And then third, find the overall charge of the entire molecule. And so an easy way to do that is you can create this handy dandy graphic chart that illustrates the equation that we learned. It's because it has the valence electrons, has the non-bonding electrons, has the bonding electrons divided by 2, and at the very end you can calculate the overall charge. So for the first part of it, let me just erase all this real quick. First part, we're going to find the charge, formal charge of nitrogen. So how many valence electrons does nitrogen have? 5. It has 5 valence electrons. If you refer back to your periodic tables, so it has 5 valence electrons. How many non-bonding? So a non-bonding electron pair, right here. These have them. Oxygen has them. Nitrogen does not. It gave them all away. So has 0. So bonding electrons. Remember back earlier we talked about how you count each bond as 2 electrons. So we're going to count each bond around nitrogen as 2. So 2 right here, 2 right here. So 4, 6, 8, 10. So it's going to have 10 bonding electrons, and then you're going to divide it by 2. So subtract everything from one another. 5 minus 0 minus 10 divided by 2, which is 5. You have an overall charge for nitrogen as 0. So just go back to your NO3, put a little 0 right here. So there's 2 different oxygens right here, and there's one right here. It's different. So these 2 are very much one and the same, so we don't have to differentiate one another. So right here, we're just going to put O1 for these 2 right here. O1. And this one's O2. So for O1, same thing as nitrogen, we're going to go through the process. How many valence electrons? We're going to go for the outermost formal charges. So valence electrons, oxygen has 6. So we're going to put down 6. How many non-bonding? So for each of these, they'll have 1, 2, 3, 4. 4 non-bonding electrons. So we write a 4. And then 2, 4. 4 bonding electrons divided by 2. So 6 minus 4 is 2, minus 4 over 2, or 4 over 2 is 2, is 0. So for both of these right here, both of these oxygens have a formal charge of 0. They have no charge. They balance out the positive to negative ratio. So this one right here, oxygen 2, O2, this one's mysterious. It's a little bit different than those other guys because it only has 1 bond. So remember, if we refer back to the NO3, it has a negative charge. So we're going to figure this out. So just by process of elimination, we know this oxygen is going to have the negative charge, not because I just erase it, but because process of elimination. So O2, we're just going to go through the same process just to kind of ingrain it into your brains, illustrate it again. So valence electrons, oxygen has 6. For this one, the non-bonding electrons is different. So it has 1, 2, 3, 4, 5, 6. 6 non-bonding electrons. You understand where that's coming from? For each pair, there's going to be 2 for each pair. And then for the bonding electrons, it's only going to have 2 over 2. So 6 minus 6 is 0 minus 1. This is where the negative 1 charge is going to be at. So in O3, negative 1 charge, that's where it's going to be. So when you're writing this, after all this craziness, after finding all the formal charges, in this will be the final illustration of the formal charge. And so now we're going to discuss why it's arranged that way. And the reason being is it's called what I just drew right there is called a Lewis structure. And a Lewis structure is a way you can illustrate the relationship between an element and the bonding and non-bonding electrons. Named after Gilbert Lewis. Lewis structures are. Lewis structure is a great way of illustrating formal charges. So carbon tetrachloride, we're going to get back on that. How are we going to start about drawing it? So usually when you look at any kind of element or compound in this case, you want to look at the first one, and that's going to kind of be the center. So previously it was NO3, nitrogen was in the middle, carbon's going to be the one that we're going to focus on. So carbon, tetrachloride means 4, so Cl4, so it's going to be 4 chlorines. So from here, what do you think's missing? From what's missing from here, what's different from there is we do not have the non-bonding electron pairs. And so chlorine, valence electrons are 7, we got to put the non-bonding pairs. So chlorine has 7 valence electrons. For this, it's going to have 6 non-bonding electrons, which equals 3 lone pairs, and it's going to have 1 electron that's bonding to the carbon. And so this is what a Lewis structure looks like. And so now we're just going to wrap it all together. We're going to figure out what the formal charge for, we're going to find the Lewis structure for SO4, and then figure out the formal charge for it. So SO4. Just give you a couple of minutes. Just write that down in your notebooks. For the sake of this video, to save time, we're just going to illustrate a passage of time. And now I'm going to go into the part where I discuss to the students how to solve this. So we're going to go back to refer back to the chart that we had. But first things first, we're going to discuss how sulfur is in the middle. Sulfur's in the middle. There's 4 oxygens. So sulfur, oxygen, oxygen, oxygen right here, oxygen right here. So this will be the Lewis structure for it. And so since this has a double bond to oxygen, it's going to have 2 lone pairs. Same thing down here. Since it's a single bond to oxygen, it's going to have 3 lone pairs, as well as a negative charge for both of these. And so now we're going to go find the formal charge for the entire thing. And so we're going to create that little handy dandy graph again. And so same thing like with NO3. We're going to make these two the same and these two the same. And sulfur is all by itself. O1, O2. So valence electrons, sulfur sit right underneath oxygen, so it has 6. So it's going to have 6 valence electrons. Non-bonding electrons, it has 0 because it's binding all of them. So 0. Bonding electrons, it has 6 binding sites. So 2, 4, 6, 8, 10, 12. 12 divided by 2 for a net charge of 0. And so now for the first oxygen, these two, we're going to go with these two right here. The ones that have double bonds, they're going to be O1. And so it also has a valence electron of 6. Non-bonding electrons, it only has 4. For bonding electrons, it has 2, 4. 4 divided by 2. So 6 minus 4 minus 2. That also has an overall charge of 0. And then now for the oxygens right here, for O2, 6 valence electrons, non-bonding, it has 6, so minus 6. And then for bonding electrons, it has 2 divided by 2 for a charge of 1. And so since there's 2 of these, 2 negative charge, that's where you get the 2 minus. And that's pretty much all we have today for formal charges.